Hello and welcome to the OpenBrIM Platform. In this video, we'll show how to import a LandXML file and create a roadway alignment in OpenBrIM. Typically, an alignment exported from software such as OpenRoads or Autodesk Civil 3D. If you haven't exported your alignment yet, we have two short preparation videos that walk through the export process from those tools. You can watch those first, then come back here to complete the import into OpenBrIM. Let's begin. First, click the Project Site button on the left side. Before we import the LandXML file, we'll define the project's Geographic Coordinate System. This ensures OpenBrIM interprets the LandXML coordinates correctly and places the imported alignment at the correct real-world location. If you're not sure about the coordinate system yet, you can skip this step and still import the alignment for analysis and 3D modeling purposes. However, the bridge will not appear in its true, real-world position on the map. You can always re-import the alignment later and assign the correct geographic coordinate system once that information is confirmed. Click the Add button for Coordinate System near the top center of the screen. In the window that opens, click Category and select the state where the project is located. For our example, we select California. If the state is divided into zones or regions, click Asset and select the appropriate zone. Here we select Zone 5. Then click Import, and the coordinate system is added to the project. Now we're ready to import the alignment from LandXML. Click Import. LandXML is a standard exchange format used to transfer civil design data, especially alignments and profiles, between engineering applications. Select the LandXML file you exported from OpenRoads or Civil 3D. Once the import is complete, click Close. The roadway alignment from the LandXML file is now created in OpenBrIM, using the coordinate system we selected. Next, we'll confirm the local origin. Local origin is the project's internal reference point that OpenBrIM uses as the 00 base for model coordinates, helping maintain numerical stability for 3D rendering. You have a couple of practical options here. You can use the Specify Local Origin button and simply pick a point close to your bridge. This is often the best choice, because it keeps coordinate values small and reduces the chance of precision or rendering issues. You can also use the alignment start point as your reference, which is a common and reliable workflow. If you don't select a specific point manually, OpenBrIM will automatically set the local origin to the start point of the first alignment imported into the project. If you are working with federated models, it's important to use the same local origin value across all OpenBrIM models within the project. Consistent local origin settings ensure that separate models align correctly when combined or reviewed together. Now return to the project screen using the Back button. To bring the alignment into view, click Zoom Extents in the upper right corner. Your imported alignment should now be visible on the screen. We also provide an option directly in the spreadsheet. You can set the project local origin to match the alignment's latitude and longitude values by using Set Project Local Origin to Alignment Latitude and Longitude. This is a quick way to ensure the project reference point is consistent with the imported alignment location. Now let's review the alignment data. In the Data spreadsheet, click Bridge Geometry, then click Roadway Alignment. Here, you can see key properties such as start station, start azimuth, and location information based on the imported alignment. Offsets are not required for a typical main project alignment. In most cases, you can leave the offset section as is and continue. You may only use offsets in advanced cases, such as when you want to define a separate reference line for girder lines or deck edges that do not follow the main bridge alignment. If your girders or deck edges have complex geometry, please watch our other video that covers those workflows. You can find the link in this video's description. When you import a LandXML file, OpenBrIM brings in the horizontal geometry and the vertical profile of the alignment. Cross slopes are not included in standard LandXML alignment data, so they are typically defined separately in OpenBrIM. Now let's click the Editor button and review the imported alignment data in the Alignment Editor. Click the three-dot icon, then click Editor. In the window that opens, you'll see horizontal, vertical, and transverse information related to the alignment. You can select any station from the tree view to review the imported horizontal curves and vertical profile. Now, let's define the crossslope. In OpenBrIM, crossslope is defined using key stations, and the platform will linearly interpolate between those stations to create a continuous roadway surface along the alignment. To start, go to the Transverse section and click the plus button. Set the station value to 14,680 and set left edge to PGL to 25 feet. Then, under Station, click the plus button and enter 50 feet for the width and set slope to 2. Next, click the plus button in the Transverse section again. Set the station value to 16,554 and set left edge to PGL to 25 feet. Under Station, click the plus button and enter 25 feet for the width and set slope to 1. Click the plus button under Station once more. Enter 25 feet for the width and set slope to -1. Once these control points are defined, OpenBrIM will automatically interpolate the crossslope between the stations. Click Accept to apply the changes. To visualize the roadway surface generated from the crossslope definition, click Settings and enable Show Roadway Surface. The transverse surface representation will now appear in the project view. Now, let's look at what makes OpenBrIM truly parametric. In real projects, roadway engineers often revise the alignment as the design progresses. When that happens, you don't need to rebuild your bridge from scratch. You can simply import the updated LandXML alignment, and OpenBrIM will update the bridge accordingly. Your 3D bridge model, finite element model representation, and drawings can all regenerate based on the new alignment data. Because cross-slope information is not included in the LandXML file, you can reuse your previous cross-slope definition instead of re-entering it manually. To do that, click the three-dot icon and select Copy Cross-Slope from another alignment. Choose the alignment you want to copy from, then click Copy. The cross-slope data is transferred to your new alignment. Your alignment is now imported and reviewed, and you're ready to begin bridge modeling in OpenBrIM. In the next video, we'll continue with the core bridge setup, starting with span arrangement and the framing plan, so you can move forward in a parametric, simple, and fast way.